Hello everyone. I hope you all are doing fine. I am Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. Today in this video I am going to discuss some more advanced concepts about a straight line in two dimension. In my previous two videos I have discussed the very concept of the definition of a straight line in 2D, the concept of the angle of inclination of a line, and also the concept of a slope or gradient of a line. We also discussed some concepts regarding the slopes, the relation between the slopes of two parallel lines, and the concept of the equation of a straight line. In the latter part of the video, I also discussed how to find the equations of lines parallel to either of the axes, that is either x-axis or the y-axis. So lines parallel to x-axis are known as horizontal lines and those parallel to y-axis are known as vertical lines. So we have already discussed the procedure to find the equation of those lines which are parallel to either x-axis or y-axis. In this video, I am taking the discussion to the next level, that is to find the equation of oblique lines. So in this video, our main focus will be the theory of oblique lines. So let us first try to understand what we mean by an oblique line. So by an oblique line, we mean a straight line which is neither parallel to x-axis nor parallel to y-axis, which means the line cuts both the axes at 2 points. So let me show you the diagram. Say this is our axis frame here. This is the x-axis, this one is the y-axis, this point being origin, and let us draw a line which intersects the x-axis at some point, say A, and y-axis at some point B. So such straight line is said to be an oblique line because it intersects the x-axis as well as the y-axis at 2 points. So such lines are neither parallel to x-axis nor they are parallel to y-axis. So such straight lines are said to be oblique lines. So these are oblique lines. Now whenever we discuss about an oblique line, it is very important to understand the concept of X-intercept and Y-intercept of such a line. So these are two important mathematical terms, X-intercept and Y-intercept of an oblique line. X-intercept and Y-intercept. So what we mean by x-intercept of a line? By x-intercept of a straight line, we mean the distance of the point of intersection of the line with the x-axis from the origin along the x-axis itself. That means if a line intersects x-axis at a point A, then distance of this point from the origin measured along x-axis. So this length OA is termed to be the x-intercept of the line. So here by x-intercept we mean the length OA. Similarly, by y-intercept we shall mean the distance of the point of intersection of the line with y-axis measured from the origin along the y-axis itself. That is the length OB is taken to be the y-intercept of the line. Now here we associate a sign convention with the x-intercept and the y-intercept. That is, in this case, in this diagram, as we can see that the line intersects x-axis in the positive direction, that is on the direction at the right hand side of origin, that is the positive direction, and it intersects y-axis above origin. So both of these are positive directions of the respective axis. So here we associate plus sign to both x-intercept and y-intercept. Whereas if a line intersects x-axis, say we consider another line like CB. So as we can see here that this straight line intersects x-axis at the point C, which is on the left hand side of origin. So this is the negative direction of x-axis, whereas it intersects y-axis in the positive direction above origin. So this is the positive direction of y-axis above origin, and this is the negative direction of x-axis. So in this case, the x-intercept OC is associated with a minus sign because the line intersects x-axis in the negative direction, whereas the y-intercept OB is associated with a positive sign. Likewise, if we have a line which intersects both x and y axis on their negative directions, likewise here. So we have a line AB, this is our axis frame, x and y axis. Here is our origin. So as we can see here, the line intersects x-axis on the left hand side portion and it intersects y-axis below origin. So in this case, both the x-intercept and y-intercept are associated with a minus sign. And finally, if we have a line which cuts x-axis in the positive direction, whereas y-axis in the negative direction, if I call this line EF, then the x-intercept OE is associated with a plus sign, whereas the y-intercept OF is associated with a minus sign. So we have to be careful while mentioning the x-intercept and y-intercept of a straight line. That is, we have to attach the proper sign plus or minus according as the line intersects x-axis in the positive or negative direction, or the line intersects y-axis in its positive or negative direction. Now let us discuss how to find the equation of such an oblique line. Now there are various forms to find the equation of an oblique line. Let me discuss the very first form, which is known as the gradient intercept form or the slope intercept form. That is the first form of the equation of an oblique line. So this is known as the gradient intercept form. Equation of an oblique line in gradient intercept form. So if this is our reference frame, and say we have an oblique line given by AB, which cuts the y-axis above origin at some point, say C. So here this is the length of y-intercept of the line, as we discussed earlier, that distance of the point of intersection of the line with the y-axis measured from the origin along y-axis itself. So OC is the y-intercept of the line. So OC is the length of y-intercept. And let us consider this length to be small c units. So here we consider that the y-intercept of the line is known to be a constant small c units. And in this case, the sign convention associated with c will be positive because the line intersects y-axis in the positive direction, that is above origin. And say the line makes an angle theta with the positive direction of x-axis, that is the anti-clockwise direction of x-axis. This angle is theta. So the slope of the line is given by tan theta, that is the slope of the line. M or slope of the line is given by tan theta. So here these two parameters c and theta are known. That is, the y-intercept of a line is given and the angle of inclination of the line with x-axis is also given. we have to find the equation of this line. Now, as we have discussed in my previous videos, that by equation of a straight line, we have to search to find the equation of this line. We have to search a common property among the coordinates of the line, which property is satisfied by each and every point on that line. Which means if I choose an arbitrary point, say P, x comma y, an arbitrary point on this line, so we have to establish a relation between x and y such that this relation is satisfied by each and every points on this line. Then such a relation established between the abscissas and the ordinates of all the points on this line will be considered as its equation. So to establish a relation between x and y, let us drop a perpendicular from P on the x-axis, which is PM, and also let us drop a perpendicular from the point C on PM, say CN. So this is our construction. First we drop a perpendicular from the point P upon x-axis, the foot of the perpendicular being M, and then we drop a perpendicular from the point C over PM, the foot being N. So as we can see here that OCNM is a rectangle, as these angles are all 90 degree. This is a right angle, this one is a right angle, this one is a right angle. So OCNM, this figure is a rectangle, and the opposite sides of a rectangle being equal, the length OM is given by x, that is the abscissa of the point P. This length OM, that is the abscissa of the point P, which is x units, and hence CN is also given by x units, being opposite sides of a rectangle. These two are equal. OM is equal to CN and both are equal to x units. Similarly, OC is taken to be OC is taken to be C units, that is the Y-intercept of the line, and OC being equal to MN, MN also becomes C. So we have OC is equal to MN is equal to C units. So therefore, what is the length of PN? So PN can be expressed as PM minus NM. PN is nothing but PM minus NM, which is given by PM is the ordinate of the point P itself. The height of the point P from x-axis, that is the ordinate, which is y. So PM is y minus NM is C. Here NM is C. So PN is given by, this length is given by y minus C. PN is y minus C units. Now, since we have considered the angle of inclination of the line to be theta, so angle PCN is equal to angle P, if I call this point say T. So this angle PCN is equal to angle CTO, because these are corresponding angles, as the lines CT and TM are parallel. Why they are parallel? Because both of them are perpendicular to PM. CN is perpendicular to PM and TM is also perpendicular to PM. So since both the lines are perpendicular to the same line PM, they are parallel. So CN and TM are parallel. PT is the transversal. So these two angles are equal, being corresponding angles. So if we now concentrate, if we now focus on this triangle PCN, here we have a right angle triangle PCN. So in the right angle triangle PCN, tan theta, what we have, tan theta is given by PN upon CN. So tan ratio is given by the perpendicular upon base. So tan theta is given by PN upon CN. So PN is given by y minus C. PN is equal to y minus C divided by CN is given by x, that is the abscissa of the point P itself. Cn is x, and we have tan theta is nothing but the slope of the line m. So here we establish a relation between x, y, m and c given by m equal to y minus c divided by x. Or if I cross multiply, from here we have, so we have the relation m is equal to y minus c upon x, or which implies mx is equal to y minus c, or y is equal to mx plus c. So this is the relation between x and y. What are xy? Xy represents the coordinates of an arbitrary point on the line, because the point P is taken to be arbitrary. We can also choose the point P here or here or here, anywhere on the line. So this relation holds for each and every point, for each and every position on the line AB. Hence this is the equation of our oblique line AB, where m is given by tan theta, theta being the angle of inclination, and c is given by y-intercept. So this form is known as the slope-intercept form or gradient-intercept form. And as the name suggests, the slope-intercept form, because in this form the coefficient of x represents the slope and the constant term itself represents the y-intercept, and hence such a name, slope-intercept form. So whenever angle of inclination of a line with x-axis is known, that is theta is known, so m is known because m is tan theta. Whenever theta is known, m is known, and if the y-intercept c is known, we can find the equation of the line as y is equal to mx plus c, where x and y denotes the coordinates of an arbitrary point, that is coordinates of any point upon the line. So this is our first form, which is known as the slope-intercept form or gradient-intercept form. So how to apply this form while solving problems? So when to apply this form? This form will be applied to find the equation of oblique lines whose angle of inclination is known and y-intercept is known. For example, say it is given to find the equation of a line. Find the equation of a line which cuts the y-axis at a distance of 3 units below origin and makes an angle of 60 degree with the x-axis in positive sense. Positive sense means anti-clockwise sense. So say we have a problem like this. Find the equation of a line which cuts the y-axis at a distance of 3 units below origin and makes an angle of 60 degree with the x-axis in the positive sense. So if we have to draw the line will be like this, where the angle of inclination with x-axis is given to be 60 degree. That is in anti-clockwise sense. If you move from the x-axis towards the line in anti-clockwise sense, it makes an angle 60 degree with the x-axis, and it intersects y-axis at a point 3 units below origin. So here y-intercept c is taken to be minus 3 units. As we discussed earlier, that we have to associate the proper sign with x and y-intercept according as it is positive or negative. So here, since the line intersects the y-axis below origin, so we have to associate a minus sign with the length of the y-intercept. So if CA is the y-intercept, which is small c units, So here C is taken by -3 and theta is given by 60 degree. So here we have theta is equal to 60 degree, which means m value, which is tan theta, that is tan of 60 degree, is given by √3, and the y-intercept C is given by -3 units. So to find the equation of the line, we apply the gradient intercept form, which is known as y is equal to mx plus c. This is the form, y equal to mx plus c. So thus the equation to the line is given by y is equal to m is √3 times x and c is -3. So this is the final equation to the line, y equal to √3x minus 3. So thus whenever we have the angle of inclination of a line with x-axis and the y-intercept of the line, we can find the equation of the line using the slope-intercept form. Let me show you another example where also we can apply the slope-intercept form to find the equation. Now say we have a straight line, an oblique line, like this, AB, and here this angle is mentioned to be say 30 degree. The angle of the line with y-axis is given to be 30 degree. Let me draw the figure clearly. So this angle is given to be 30 degree. This is our line AB. And the coordinates of A are given to be 0,4. So the question is, a line AB makes an angle 30 degree with y-axis. Here is our y-axis. And it passes through the point 0,4, making an angle 30 degree with y-axis. So to find the equation of the line. Now how to apply the gradient intercept form in this case? Because in this case the angle of inclination is not known. Angle of inclination is always found with x-axis. So first we have to find theta, the angle of inclination of the line with x-axis in positive sense. And then we have to also find the y-intercept of the line. So here as we see that OAB is a right angle triangle, this angle being 90 degree, because x and y axis are at right angles. So therefore the angle of inclination becomes 60. So here the angle is not directly known, but indirectly from this information we can get the angle of inclination to be 60 degree. So that is our theta. Theta is equal to 60 degree. And since the line passes through the point 0,4, the point 0,4 itself being a point on y-axis, this itself is the y-intercept of the line, because y-intercept of a line means the distance of the point where the line cuts the y-axis from the origin. So the point 0,4 being a point on the line as well as a point on y-axis, the point intersects y-axis at a distance of 4 units above origin. So here the C value is 4 plus 4. So consequently M becomes tan 60 degree. Whenever we know the angle of inclination, the next step is to find the slope, that is tan theta, which is √3. So since M and C are known, the equation of the line is thus given by y is equal to mx plus c or y equal to √3x plus 4. So this is the equation of a line, where xy represents the coordinates of an arbitrary point on the line. That means each and every point on this line will satisfy such a property that ordinate of the point will be √3 times the abscissa of the point plus 4. So this is the meaning of the equation of a line, that this is the common property which will be satisfied by each and every point on this line. So whenever you take a point on this line, say if I choose a point alpha beta, then alpha being the abscissa, beta being the ordinate, so they will satisfy this relation, that is the ordinate value beta is given by √3 times the abscissa value alpha plus 4. So this is how to find the equation of an oblique line whose angle of inclination and y-intercept are known. So in the next video, we shall be discussing about another form of an oblique line, which is known as the slope point form. There are many various other forms also. So in the next video, we shall be discussing about another very important form known as the slope point form of the equation of a line, and also 2-point form of the equation of a line. So slope point form means when the angle of inclination of the line is given and a point on the line, coordinates of a point on the line is known, then how to find the equation of the line. And then in 2-point form, as the name suggests, that when coordinates of 2 points on a line are known, how to find the equation of the line. We shall be discussing those concepts in our next video. So if you have any doubts regarding today's discussion, feel free to ask me in the comment section. I hope the concept of oblique lines, the concept of X and Y intercepts, and the slope intercept form, the concept of the slope intercept form as well as its application, how to apply the form in solving the problems, is clear to you all. And feel free to ask me any questions if you have. Thank you all for watching this video. I wish you a wonderful day. Thank you.